geometry. So we have two examples here, but first of all, let's go to this example when we write a geometry with a green color. Uh, a rectangle is bounded by the x-axis and the semicircle y is equal to the square root of 36 minus x squared, as shown in the figure. So we have in the figure here. Write the area A of the rectangle as a function of x and determine the domain of the function. So let's analyze this figure here. So the rectangle here from the origin 0 to this point here is a x, this segment, but because this is a semicircle with the origin at 0, we already see is a symmetric this rectangle. Their left side and right side are symmetrical. And because it's a symmetrical, just let me take one pen here. So this x here and this segment here from 0 to this point here is a symmetrical. But we already know the area of the rectangle A is equal A times B. In fact, width times height. So the width in this case is x plus x is a 2x. So I can write 2x is a time y, the height here, time y. But we want to write the area with respect to the x, with respect to the x. We don't want to write it with respect to the y. We here have a y. So we have a 2x. And instead of the y, now we can write here y is equal with the square root of 36 minus x squared. So we can substitute instead of the y is a 36 minus x squared. And now we are looking, we already got the area with respect to the x. And now we have to find out the domain. The domain is because this is a 36, we already know the radius here is a 6. So here is a 6. And what do we know here? The x, the domain x is somewhere between 6 and 0. 6 and 0. But let me see something. But we are excluding 0 and 6. For example, if x is a 6 from here to here, and from this point to the left side to here, we already see here, we have just a segment, but we cannot have a rectangle. Even if we have a 0, for example, just a 0 here, we won't have the area. It will be just one segment 0, just a segment here. So it won't be it will not happen to have a rectangle. So even if we are looking analytically, if we include the 0 here, for example, if x is 0, 2 times 0 is 0. Whatever this side is going to get 0, so area 0. We do not have a rectangle with area 0, does not exist. Again, if we are putting a 6, if we have a 6 square is a 36 minus 36 is 0. Whatever we got here, a number, the time a 0, area is going to be 0. So that's why the domain is between 0 and 6, but excludes the value 0 and 6. So now let me take one different color for the second question here. And here we have write the area A of a circle as a function of its circumference. Let's first of all write the formula for the area of the circle. Here is saying about circle, do not have a semicircle. So do not rely on this in this figure. We do not have to do anything with this figure. We already have here circle. Area of the circle is equal with the pi times r square. So this is the formula, times r square. On the other hand, let me take a different color. On the other hand, the circumference, this is not a good. Let me take a little bit better. On the other hand, the circumference of the circle, or the perimeter of the circle, C, let me write the C, circumference is a 2 pi times r. 2 pi times r. Times r. And now we wanted to see in what relationship is going to be a circumference with the area. Because here I have a C equal to 2 pi times r, everything I'm going to square. If I'm squaring everything, I'm going to have a C square. C square is equal, so now I'm squaring the right side. 2 in a square is going to be 4. And pi in a square is going to be pi square. And r in the square is going to be pi square. And r in the square is going to be r square. But now I want this to make a pi r square, and to make it exactly like I have here, pi r square. What I'm going to do here, in order for me to solve this for pi r square, what I'm going to do, I'm going to divide by 4 pi everything. So I'm dividing by 4 pi. Divide the whole equation by 4 pi. And what we're gonna have here? So if I'm dividing by 4 pi, let me divide here by 4 pi. So I'm dividing here by 4 pi. And same thing I'm going to do in the right side of the equation, to divide it by 4 pi. By 4 pi. And now what I'm going to have here, I'm going to divide this square divided by pi, and 4 divided by 4. In other words, the 4 pi or a pi r square. Because of this, I am simplifying by 4, and pi by the square here remains just pi r square. Pi times r square is obvious. And what's happening with this pi r square? It's going to be c square over 4 pi. C square over 4 pi. And now by applying the substitution of equality, because pi r square is equal to c square pi square, and here is area is equal to pi r square, and instead of pi r square I'm substituting c square phi over 4 pi, and definitely the definite result, A, the area, is going to be equal with c square over 4 pi. So this is the final result for the second question.